All right, good day. Hope that you're doing good. So this is a video of the finance tutorial. Basically, this is the solutions video. So we're gonna start off with doing practical one, right? Now, these questions are from your previous prelim question papers, by the way. Now, starting off with question 7, it says a survey conducted in December 2015 determined that 5.7 million South Africans were living with HIV. Now, the researchers use a model of exponential growth, and this is the formula they use, right, to predict that there would be 6 million people living with HIV in December 2022. All right. So basically, here they use the compound interest formula, right, to predict that there will be 6 million people living with HIV in South Africa in December 2022. Now we need to calculate as a percentage the annual rate of increase that the researchers used for the 7 years. Now, making use of this formula, what is it that we need to calculate in this case? We need to calculate the value of I, which is the interest, right? Now let me substitute what I have already. So A, which is the future value, it will be this 6 million, because this is a number of people who would be having HIV in the future, which is in December 2022, and now we are in, or rather the survey was conducted in December 2015, right? So my future value is going to be 6 million. Let me just write it down. So punch in my formula is equals to P 1 plus my interest all over N. Now my future value 6 million. I'm going to say 6 million. Now, this 6 million is equals to my present value, which is 5.7 million, because this is the number of people living with HIV currently in South Africa. So I'm going to say 5,700,000, and then 1 plus, what is the interest? Interest is what I'm calculating, right? So I'm calculating for my I, all to the power N. Now, this research was conducted for 7 years, right? So my N, it will be 7 in this case. All right. Now, first step is getting rid of this 5.7 million. And how would I go about doing that? By dividing both sides by 5.7 million, right? So I need to divide both sides by 5.7 million. And remember, do not round off up until you get to your final answer. So this divided by 5.7 million, also the side divided by 5.7 million. All right. And these two would cancel out one another. And what am I left with now? Let me just write what I'm left with this side. Let me just draw a line here. So now I'm left with 6 million. So this 6 million divided by 5.7 million. All right. Now 6 million, and this is equals to 1. So this is equals to 1 plus my interest, and all to the power 7. Now, this is my I. Now, the next step, because I need to remove everything up until I'm left with this I. Now, the next thing that I want to remove is this exponent 7. And how would I go about removing the exponent? By using a root. And in this case, I would look for the 7th root on both sides, right? I'll just substitute in the 7th root on both sides. So also the side 7th root. Now, this 7th root would cancel out with this exponent 7. Now, as a result, you would be left with, right, the 7th root of 6 million. Right, let me just write this down. So it's basically 6 million, all divided by 5.7 million. Right, and this is equals to what? This is all equals to 1 plus your I. Now, I need to solve for my I, and the next step here, remember, we're removing everything up until we're left with this I. The next step is simply just transferring this 1 to the other side, right? So that you could be, so if I transfer this 1 to the other side, it would now be a negative, right? So basically here, okay, let me just write it here. So this would be -1, this side, and this side, you would be only left with your I. Now your interest is equals to the 7th root of 6 million divided by 5.7 million minus 1. And this -1, do not include it in this 7th root, right? It must be outside. Now, punching this into your calculator, right, you would get a decimal, by the way, right? And that decimal, you need to multiply it by 100. Why? Because you're looking for a percentage. Now, if you multiply this by 100, your interest should be equals to, which is your value of I, 0.74%. All right. Now, this is answer for 7.1. Now, let's move into 7.2. Now, 7.2, they say, Shimi invests, right, 4 million into an account earning an interest of 6% per annum. So this is the amount he invests. Okay, let me just highlight that. Now, how much is this account earning? 6% per annum, all right, compounded monthly. Now, they said she withdraws 30,000 per month, right? So this is another information that, let me highlight it using a different marker. So she then withdraws 30,000 per month. Her first withdrawal is exactly 1 month after she deposited the 4 million, right? Now, let me just write this down. Let me just process this, right? So initially, this person invests 4 million, right? So initially, this is how much they invest, 4 million. All right. And now this is the interest they are earning, right? And then they said what? They said now she goes on it by withdrawing 30,000 per month, right? Her first withdrawal is exactly 1 month after she deposited the 4 million. Now, the first question that you need to ask yourself is that, remember, there are two types of questions, right? Rather, three. One, is it a simple interest question? Two, is it a compound interest question? Right? Remember the formula for your simple interest and your compound interest. Now, thirdly, is this an annuity? Right? And what is the definition of an annuity? Annuity is a series of equal payments, right? Not only equal payments, but it could also be withdrawals, right? Series of equal payments or withdrawals made in regular time intervals, meaning that if you're making payments, let's say, for example, a payment, right, or you have a savings account, in order for that savings account to be an annuity, the payments need to be equal, meaning that if you invest, or rather if you save 5,000 per month, for the duration of the savings account, you need to invest or save that 5,000. It mustn't change. And it must also be on regular time intervals, meaning that if you decide to save on the 15th of the first month, this simply means that going forward, of each month, you need to save the same amount you did the last month. Now, in this case, this is an annuity. Why? Because she withdraws 30,000 per month. This is a constant amount or fixed. It doesn't change, right? And also on a consistent basis, right? Or regular time intervals, which is per month, right? Meaning that we can either choose between two annuities, future value or present value. Now, what is this? This would be a present value. Why? Because this 4 million, it is the amount that she invests now. Hence, this would be a present value question. Now, the first thing that I'm going to do is that I'm going to write down my present value formula. Remember, this present value formula is not given at the back of your question paper. You're only given your future value formula. Now, this is equals to, so it's my x square brackets 1 minus 1 plus interest to the power minus n, close bracket, and everything to the power I. Now, here the question that you need to ask yourself, what is it that they're requiring you to do? You are required to calculate your n, the number of withdrawals that she would be able to make. All right. So in this case, let us go about doing that. So that's substitute what we given. What is our present value? We said our present value is going to be equals to 4 million. So this is going to be 4 million. It's equals to, what is our value of x? X is your withdrawals in this case, and it's 30,000. So here is 1 minus 1 plus, what is my interest here? My interest is 6% compounded monthly, which is going to be 0.06, right? 0.06. And because it's compounded monthly, I need to divide the 0.06 by 12. And all to the power minus n, which is my only unknown variable in this case. Now, this must be divided by your I, so let's say brackets. Even if you can write 6%, as long as in your calculator you would punch it in as 6% over 12. Right? Now, what is the first step here? Now, the first step is that I need to remove this denominator, right? And how would I do that? The only way I can remove this denominator, because it's dividing, I need to do the opposite of division, which is multiplication. So I will multiply both sides by 6% over 12. So this side multiplied by 6% all over 12. Same applies to this side. All right, and these two would cancel out one another, right? So let me just erase them. Now, punching 6% over 12 multiplied by 4 million into a calculator, you should get an amount of 20,000. Or rather, let me just write it here. So this would amount to 20,000. All right, now, next thing that I want to do is to get rid of this 30,000. Now, how would I go about doing that? Dividing both sides by 30,000. So here I would say divide by 30,000. Same applies to this side. What you do on the left, you must do on the right. Divide by 30,000. And these two would cancel out one another, right? So now, if I say, now if you take 20,000 divided by 30,000, punching it into my calculator, it would give me 2 over 3. So this side I would get 2 over 3. Let me just this is 2 over 3. Now these two would cancel out one another, right? Let me just remove them. Now the next step, I will take this one to the other side, right? So that it will become minus 1. Okay, now I will remove it here because it was a positive here. So also this would be like this. 2 over 3 minus 1. This is equals to negative brackets 1 plus 0.06 divided by 12, all to the power minus n. Now, if I take my 2 over 3 and subtract it by 1, I should get negative 1 over 3, right? It's equals to, now if I punch this into my calculator, right? 1 plus 0.06 divided by 12. Let me see how much it will give me. So this would give me 201 over 200. But remember, there is a negative outside which multiplies everything, right? So this would be negative, which is this negative. And inside this bracket, when I punched it into my calculator, is 201 all over 200. And remember, this is to the power negative n. Now I've removed everything up until I'm left with this, right? Now, what is the next step? Now, because both sides are negative, these negatives can cancel out one another. Let me just highlight them. So this would cancel out with this negative. So as a result, both sides would now be positive, all right? So we have positive 1 over 3 this side, and this side we have 201 or positive 201 over 200 to the power negative n. Now, remember, we said every time whenever you solve for exponents, you need to make use of logs, right? So in this case, I will just see this. Let me just draw this using a different marker. So I would say my minus n So I would say my minus n, it is equals to the log of, now my base is anything that was attached to my minus n, and this in this case it will be 201 over 200. This would be the base of my log. Right? And my exponent should be whatever that's on the other side. So what's on the other side is 1 over 3. Right. Now, punching this into your calculator, your negative n would be equals to negative 220, comma 27. Now, because both sides are negatives, these negatives can cancel out one another. As a result, both sides will be positive, right? Now, your n, in this case, it will be 220, comma 27. And how many withdrawals would she be able to make? Now, she would be able to make 220 withdrawals, right? Now, you can just round this off and say she would be able to make 220 withdrawals. Now, moving on to 7.2.2, they say how many withdrawals will she be able to make if she changes the amount of withdrawals per month to 20,000, meaning that now she's no longer withdrawing 30,000, but 20,000. Now, let us solve for that, right? So basically, we now be solving for n again, but let's substitute what we have. So we're going to be making use of this present value formula again. Now, in this case, what will our present value be? Now, present value would still be 4 million, right? Let me just write this using a different marker. So it would still remain 4 million. Now, what is our x? X would now be 20,000. And this is 1 minus 1 plus our interest didn't change, so it's still 6% divided by 12 all over 12 all to the power minus n. And this, remember, it's divided to your I, which is 6%, and it's compounded monthly, hence we're dividing it by 12. All right, now the first step, it will be to multiply. So the first step, it will be to multiply this 4 million, right, by this 6% over 12, right? And if I multiply both sides, this side you would get 20. If I multiply both sides, I will get 20,000. Now this would be 20,000, and this 20,000 is equals to 20,000 multiplied by this. Now the next step is dividing both sides by 20,000. Why? Because I need to remove this 20,000 here. So let me just do it. Okay, let me just do it using this marker. So next step, dividing both sides by 20,000. so that these two can cancel out one another. What you do on the left, you must do on the right. So if I divide this size by 20,000, it's going to be equals to 1, right? So this is going to be equals to 1. Now let me just simplify that. So number 1 is going to be equals to this, right? Now, what is the next step from here? Now, the next step is that, remember, I'm trying to remove everything up until I'm left with this part right over here, 6% over 12 to the power minus n. Now, and also this plus 1. Now, the next step, I need to remove this 1. How can I go about removing it? By just transferring it to the other side. And it would be now be negative 1. So as a result, the other side would be equals to 0. So let me just erase this. So now this would be 0 is equals to, now, negative in brackets 1 plus 6% over 12 to the power minus n. Now, remember, whenever you're solving for logs, right? So basically, whenever you're solving for, now remember, whenever you're solving for exponents, you need to make use of logs. So your minus n, in this case, it should be the log. Now my base is whatever that was attached to this minus n. And my base in this case would be 1 plus 6%. And this is divided by 12. And my exponent is whatever that's on the other side, which is 0. Now, punching this into your calculator, right, you should get negative infinity. But then this would only show whenever you have a scientific calculator. I'm not sure with the kind of calculator that you use, right? Now, as long as here you didn't punch in any negative number, right, both these numbers are positive. Now, if it gives you error in that case, I'm not sure if you know calculator to show infinity or error, right? Now, in my calculator, it shows negative infinity. So in your calculator, it must show error. So these negatives would cancel out one another. And as a result, my n should be equals to positive infinity. Now, let me explain this why, or what does this mean? This simply means you can make number of withdrawals. Why? This simply why? Because the 4 million, right? Remember the present value that she invested, which is 4 million. Your 4 million would earn, or rather, this means that the 4 million that you invested would now earn an interest of 20,000 per month, right? This is the interest you earn, your I, which is from your 4 million you invested. And that I is equals to 20,000. This is the amount you are getting from the bank. And you always, or every month, you're making withdrawals of 20,000, right? So your withdrawals are also equals to this 20,000. Now, this simply means that whenever you withdraw money, you only withdraw your interest, not only your not your capital amount, which is your 4 million. So your 4 million would remain unchanged, right? So your present value would be 4 million, and every month it would earn an interest of 20,000, and you would also withdraw 20,000 because now your monthly withdrawals are 20,000. So this simply means that your 4 million is not affected. Hence, you can make infinity or infinite number of withdrawals. I hope this makes sense. If ever you have any questions, always feel free to reach out, right? Now, this simply means that the interest that you make is equals to the withdrawal that you make. So your 4 million earns an interest of 20,000, and you're making withdrawals of 20,000. Hence, you can make an infinite number of withdrawals. Now, moving on to the next question, they say Street opens a savings account now with a single deposit of 1,000 rands on 1 April 2022, right? Now, they say she then makes 18 monthly deposit, right? Then afterward, she then makes 18 monthly deposit of 700 at the end of every month, right? Her first payment is made on 30 April, right? And what other information did they give us? Her last payment. Okay, let me just highlight that this in this. And her last payment is dated, it's on the 30th of September. Now, the interest is 15% per annum compounded monthly. We need to determine the amount that should be in her savings account immediately after the last deposit is made. Now, in this case, this person starts by depositing 1,000 rands on 1 April. Then month end, she then makes, or rather from the 30th of April, she then starts making monthly deposits. And how many are those monthly deposits? 18, right? Meaning that for every month up until the 18th month, she made deposit of 700, right? Now, her first payment was made on 30th April 2022, and her last payment is made on 30 September 2023. Now, this is the interest that the account is adding. Now, there are two types of questions here, or rather two scenarios. One is a fixed deposit, which is this one, right? And what kind of a fixed it's a fixed deposit question, bro. So one is fixed, other one. The other one is an annuity. Why? Because she was making a series of equal payments on regular intervals, 700 rands at the end of every month, right? Now, this is an annuity question. Now, in order to go about doing this, you need to calculate the future value of this fixed amount as well as your future value of this annuity separate, and then you add the two. Then the two future values will give you the amount that should be in her bank account at the end of the last deposit, or rather at the time of the last deposit. Now, Let's start with this part, because here we say this is a fixed deposit question. There are two types of question. It can either be a simple interest or a compound interest. Now, in this case, because our interest is compounded monthly, this simply means that we're going to make use of our compound interest formula, which is A is equals to P1 plus I to the power n. Now let's substitute what we have. We're looking for a future value, which is A, and in this case, what would be our present value? They say he made a deposit of 1,000, so our P would be equals to 1,000 rands, and in this bracket it's 1 plus. Now our interest rate is 15%, so it's 15, and this is compounded monthly. Now, what is our N? Now, in this case, the thing with fixed deposit that I want to explain, right? So whenever you invest, so if you can count from 1 April up until 30 September, right? Counting from the 1st or starting from April, it would be 19 months, right? But then what I want to explain in terms of fixed deposit is that if you make your deposit on the 1st, your interest, or rather your capital amount which you have invested, would start earning interest month end, right? Meaning that it makes sense, because when you invest money on the 1st, you would only get your interest month end, right? So in this case, whenever you start counting, you would not start from the 1st of April, but you would start from the 30th of April, because that's when this fixed deposit started earning interest, right? Because you cannot deposit money today on the 1st and your account starts earning interest today. It would earn interest after 30 days. Why? Because your interest is compounded monthly. So we're going to start off from 30th April up until 30 September, and this would be 18 months. So in this case, our N, it's 18, right? Now, punching this into your calculator, your future value, right, which is the amount that this fixed deposit of 1,000 would make, it should equals to, so it should equals to 1,250, right, comma 58. Now let's do for our annuity. Now, there are two types of annuity questions. One is a present value. The second one is your future value. Now, in this case, what do you think is the appropriate formula we're going to use here? Now, in this case, we're going to be making use of your future value formula. Why? Because you're looking for the future amount, or the amount in the future that she would earn if she invests or saves 700 rands per month, right? So you would say, punch in your formula, which is given at the back of your question paper. Future value is equals to your, now your X, which are your payments. So this is 1 plus I to the power n minus 1 all over I. Let me just confirm this, because I think I have a formula sheet here. Okay, here's the formula. 1 plus I to the power n minus 1. Yeah, I think this is correct. All right, now let's substitute what we have. Our X, which is our payments. The payments were 700 rands per month, so my X is going to be equals to 700 rands. So 1 plus my interest of 15%. Because remember, this is the same account, right? 15% is compounded monthly, hence we're dividing it by 12. Always remember to adjust your I, right, as well as your N. Now, the number of months here, or the number of deposits, they are 18, right? So our N is going to be 18, which represents the number of the deposits, minus 1 all over our interest. Now, our interest is 15%. But remember, this 15% is compounded monthly, so we're going to need to divide it by 12. All right, now you need to punch this into your calculator. And if you punch it, into your calculator, you should get 14,132. So it's 14,132,33. Right? Now remember, the amount that should be in his or her bank account, or rather in this case it's a her, you need to add these two, right? So basically that amount would be 1,250,58 plus 14,032,33. Now punching this into your calculator, you should get an amount of 15,282,91. Right? Now, I hope this makes sense. If ever you have any questions, always feel free to reach out. Now let us move on to the next practical, which is practical 2. Now, starting off with 7.1, they say at what annual interest rate, right? Meaning that we need to calculate I, compounded quarterly. This I is compounded. should a lump sum be invested in order for it to be double in 6 years? Now, first, remember, you need to identify what kind of a question is this. Now, a lump sum is a once-off payment, or rather deposit, right? Now means that it's a fixed payment. Now, we need to choose between a simple interest and a compound interest. Now, because here our interest rate is compounded, we're going to be making use of our compound interest formula, right? Which is A is equals to P, open bracket 1, plus I. Now, in this case, they say this interest rate is compounded quarterly. So I need to divide this I by 4. And all to the power n, right? So what is my n? My n is 6 years, and that's 6 I need to multiply by 4, right? Let me just say 6 multiplied by 4. Now my n, 6 multiplied by 4, is going to be 24. All right, so it's I, which is what I'm looking for, divided by 4 plus 1. And let me substitute in my present value as well as my future value. Now, here they say at what annual interest rate, right, compounded quarterly, should a lump sum be invested in order for it to double in 6 years? Meaning that if, for example, if I want to invest 2,000, right, at what interest rate should my investment account be so that this 2,000 at the end of 6 years, it could be 4,000? So meaning that any amount that you invest, it should double whenever you're using this interest rate. So we need to look for that interest rate. Now I can make this in terms of X, saying that if I invest my X, which is my present value, right, I need to find I, the interest rate, which would double my initial investment. Now, meaning that in the future, I should get double X, which is 2X. All right, now this is your standard formula. Now you need to solve for I. Now the first step I'm going to try to, we apply the normal elimination steps, if you could see. So now if remember on previous examples, the first step would try to remove this present value by dividing both sides by present value. Same principles applied in this case. So we're going to divide both sides by X. Same applies, this side divided by X. Now this X is going to cancel out with this X. Same applies with this X. It's going to cancel out with this X right over here. So overall, you're going to be left with 2 is equals to, now let me just remove this. So your 2 is equals to 1 plus I over 4 to the power 24. Now, what is the next step? Now, the next step, I'm going to try to remove this 24. And how would I go about doing that? So I would find the 24th root, or rather plug in the 24th root on both sides. So this to the 24th root. What I do on the left, I must do on the right. 24th root. Now remember too, it's important, do not round off up until you get to your final answer. Now I would continue with these sets. Now, in this case, the 24th root of 2. Now this is equals to 1 plus I over 4. All right. Now, next step is that I'm going to take this 1 to the other side, basically transfer this 1 to the other side, and it will become a minus, right? So let me just do that. Now, the next step from here is that I need, remember I'm solving for my I, not I over 4. So I need to remove this 4, which is dividing this I. And by doing that, I need to do the opposite of division, which is multiplication. So I would multiply both sides by 4 so that these two could cancel out one another. Now here, just put brackets here. And also when you do this into your calculator, place brackets and say this is multiplied by 4. All right. Now, punching this into your calculator, right, your I should be equals to 0.1172. And because you're looking for a percentage, you need to multiply this by 100 so that your interest should be equals to 11.72%. Now, this simply means that if you enter, or rather you invest any amount at this account which earns an interest of 11.72% compounded quarterly, right, you should be able to get double that investment using this interest which is compounded quarterly. I hope that makes sense. If ever you have any questions, always feel free to reach out. Now let us move on to the next question, which is 7.2. Now let's go to 7.2. Now 7.2, Simon, who buys a furniture to the value of 10,000. Now, in order to buy this furniture, he borrows money on the 1st of February 2020, right, from a financial institution which charges an interest rate of 9.5% compounded monthly. All right. Now he agrees to pay monthly installments of 450. Okay. Basically, let me just highlight this. So he agrees to pay monthly installments of 450. The agreement of the loan allows him to pay equal monthly installments from 1 August 2020. Now, what type of a question is this? This is an annuity. Why? Because he would be paying 450, which is equal amounts of installments on regular intervals, meaning that per month, right? Hence, this would be a annuity question. Now, I said always any questions involving loans would form part of your present value, or you would make use of your present value formula. Why? Because when you're getting a loan, the banks gives you that money you want now, and that money that you have borrowed would be what? Your present value. Now, in this case, Simon wanted to buy furniture of 10,000, and he went to the bank to borrow this money. Now, the bank gave him the 10,000 now, hence this 10,000 would be your present value, right? Now, they said he would start paying on the 1st of August 2020. Okay, remember he borrowed the money on 1 February, but he would only start paying on 1 August 2020. Now, between this period, the interest is still charged even though he's not paying, right? But let us look at what the question requires from us. 7.2.1 says calculate the total amount owing to the final institution on 1 July 2020, right? So basically from 1 Feb, let me just write. So from 1 Feb to 1 July 2020, we need to calculate the total amount owing to the financial institution. Now, how would I go about? Can you agree that from 1 February up until July, this person wasn't paying any installments because he started paying on 1 August 2020, right? So this simply means that the formula that we're going to make use of here it would not be an annuity, because why? He started paying on August, not on July, and August it was way past, or rather it was after July, right? So from 1 Feb to 1 July, we need to calculate the amount that he owed. Now we would make use of our compound interest formula. A is equals to P1 plus I all to the power n. Now we're calculating A, the amount, or rather we're calculating the total amount owing to the financial institution, which is A in this case. Now the present value, which is the amount he borrowed, he borrowed 10,000. All right, so this is 1 plus my interest rate of 9.5%. So I'll say correct 9.5. Now this 9.5% is compounded monthly, hence I'm going to divide it by 12. Now my N. So from February, so it will be February, March, April, May, June, right? It's 5, because remember it's 1 July, so you do not include July. So this is going to be 5 months. Now I'm writing it in terms of months. It's fine, because why? My interest is also compounded monthly. Now punching this into my calculator, the amount that this person is owing on 1 July, right? It should equate to now 10,402, comma 15. Now our X, which is our monthly payments, they would be equals to 450. So this should be 1 minus 1 plus my interest. Now my interest is 9.5%, but this 9.5% is compounded monthly, and so I'm going to divide it by 12, all to the power minus n. Now in this case, n, which represents the number of payments, right? Now n, it should be equals to 18, right? So we said, okay, the agreement of the loan. Now all to the power of minus n, which is what I'm looking for, my unknown variable. And my interest is the same here. It's 9.5%. All to the power of 12. Now, what is my present value? Remember, this person didn't start by paying the loan immediately. He started paying for the loan on 1 August. Right? Hence, my present value, it would be the amount that he owed on 1 July 2020. So in these kind of questions whereby they say 7.2, and you find 7.2.1, 7.2.2, 7.2.3, just like in this example, the amounts you use to calculate, or the amounts you calculate at the beginning, you would use them on your preceding questions, right? You're most likely going to make use of them. Now, here, you need to make use of this 10,402,15. Now, even if this amount is wrong, but for the mere fact that you took this and substituted it here, you would get a mark for that. So it will be 10,000. He's owing 10,402, comma 15. Right now, I've substituted everything. I just need to solve up until I get my value of n. Now, the first step, I'm going to try and remove this denominator. And how would I do that? I would multiply both sides by this 9.5% over 12, right? I would multiply both sides by this 9.5% over 12. And if I multiply it this side, it would cancel out with, if I take 9.5% divided by 12, multiplied by this, it would cancel out with this. Now let me see if I take 9.5% divided by 12 and multiply it by 10,402.15. How much would I get? Now punching that into my calculator, I would get, if I punch it, I got, okay, it's 3,952. Now this should be removed. All right, now the next step. My next step is that I'm going to try to get rid of this 450 by doing what? Divide both sides by 450, right? So I'm trying to get rid of this 450. Now let me see if I punch this into my calculator, how much would I get? Now that divided by 450, it's giving me 3,952,817. So here it's a 7. Okay, let me just write this afresh. All right, so I get 3,952,817 all over 21,600,000, right? So these two, as I've said, they will cancel out one another. So this is what I'll be left with. Now, what is the proceeding step from here? The next step here is that I'm going to take this one, right, and transfer it to the other side. So it would become -1, right? Let me just do that. So this would be -1, and this is all equals to, so now I can remove the square brackets. Okay, let me just take that negative back. So this, remember, it was minus here. So it's all equals to -1 plus 9.5% divided by 12 to the power minus n. All right. Now, let me punch this into my calculator and see what value would I get. Let me just simplify this amount. Right, when I punch this into my calculator, I get -17,647,183, all divided by 21,600,000. Right. So because both sides I have negatives, these negatives can cancel out one another, so that both sides can now be positive. All right. So these negatives cancel out one another. Now, what is the next step from here? Now, my next step is to solve for my n, right? So remember, to be your negative n, write it as it is equals to the log. So you base it to whatever that was attached to your negative n. Now, in this case, what was attached? It's the 1 plus the 9.5% divided by 12. And then your exponent is whatever that's on the other side. Now, what's on the other side? It's 17 million. Now, punching this into your calculator, right? Your minus n, it should be equals to negative 25.7. But because both sides are negative, these negatives can cancel out one another, and both sides will now become positive, right? So basically your n is equals to 25.7. Now they asked us, what was the question requiring us? How many months will it take for Simon to pay the loan? Now you need to round off because your month cannot be 0.7, right? So basically here, you would need to pay this off within 26 months, right? Now this should be your final answer, right? Now let's proceed to the next question. Now, 7.2.3, they say, what is the balance of the loan immediately after Simon made the 25th payment, right? Now, remember, your n represents the number of payments, right? And we said, how many months would it take Simon to pay? 25.7, right? Now, in this case, they said, but then remember, your final answer was rounded off to 26. But if we're going to make use of these amounts, we do not round off up until we get to the final answer. So we're going to make use of this amount, which is not rounded off. Now, in this case, remember, I said anything that has to do with loans, you're gonna most probably use your present value formula. Now, in this case, you can continue with your present value formula, right? Let me just write it down and then I'll explain why afterwards. Now, here is our present value formula, right? So we need to look at what is the balance of the loan immediately after he made his 25th payment. Now, the reason why we're still using this formula is because this is the second last installment. Now, basically here they're looking for the balance of the loan, which would be the last installment that Simon needs to make, right? Now we're looking for the balance of the loan immediately, right? Right after he paid on the 25th payment, right? How much was he now owing after the 25th payment? So let us substitute what we have. So our X, which is our monthly repayments of 450, square brackets, 1 minus 1 plus my interest rate, which is unchanged. So it will be 9.5 all to the power minus n. Now, what is my n? So to get my n, I would say this 25.7 minus 25, and this would be 0.7, right? So this would be 0.7 months. This is the remaining months, right? Because we're looking for the amount of loan owing in the remaining months. So remember, this is a negative, so it's minus. Now, close square bracket. Now my I is still 9.5%. Now, because it's compounded monthly, I need to divide it by 12. Now, punching this into your calculator, right, the amount that Simon should be owing after the 25th payment, or our present value in this case, should amount to 200 and so it should be R. And also, I forgot, you should put this whenever they ask you anything in terms of money, always put the currency. Right now, this is in terms of rands, so this is R2. Always on your answers, remember to put the currency. So 282, 36. This is how much he's now owing, and this would be his last installment, right? The amount that he would pay in the preceding month, which would be the 26th month. This is the amount. Okay, now let's look into the last practical, which is practical 3. Now proceeding, starting off with 5.1. They say Table bought a car. Let me just zoom this in. All right, Table bought a car for 180,000. All right, this is how much he bought the car for. The value of the depreciated, okay, the value of the depreciated, I think they wanted to say, okay, the value depreciated at 15% per annum according to the reducing balance method. Right now, they say the book value of Sandile's car is currently 79,886. All right, now the question says, how many years ago did Sandile buy the car? Now, another word for your compounding method, it is reducing balance, right? Just know that whenever they see that you must use the reduced balance method, this simply means you must use the compounding method. Because remember, this is a fixed investment kind of question, right? Meaning that it's not an annuity. So you need to choose between simple interest and compound interest. And I'm saying the other term for your compound interest is reducing balance method. Now, in this case, you're going to make use of this formula. Okay, let me just write it here. So your A is equals to your P. Right now, let us see. This is a depreciation question. So you're going to make use of your normal formula, but instead of putting a plus, you're going to put a minus. Because why? It is a depreciation question. Something loses value. So at least here they specified it straightforward. So 1 minus I all to the power n. And I am solving for this n. Now let me substitute what I have. Now he bought the car for 180,000. All right. And the book value of Sandile's car is currently 79,866. Now, before it was 79,866, right? It was 180,000 first, right? And then it went on reducing value to being 79,000. Hence, our present value, it would be 180,000. So it started off as 180,000, right? 180,000. Then in the future, it reduced to 7,9,866. Right? My handwriting, sorry about it. So, 0.96. Now 1 minus my interest, which is 15% per annum. All right, so you could just write 15% only. In this case, there is no need to divide it by anything because it's not compounded quarterly or monthly. Right, now we're solving for n. All right, now what could be my first step here? Now my first step is to get rid of this 180,000. And how would I go about doing that? By dividing both sides by 180,000. So divide both sides by 180,000, and this would cancel out with this. And this, I need to divide by 180,000. All right, now let me just punch this into my calculator and see what value would I get. Now, as I've said, these two would cancel out one another, this 180,000 and this 180,000. All right, now this one I will just leave it as it is because even though I punch it into my calculator, it still gives me a fraction. So basically, this is equals to this. So 79866,96 all over 180,000. This is equals to 1 minus 15% to the power n. And now if I simplify this 1 minus 15%, right, or punch it into my calculator, I get 0.85. So okay, let me just write this properly. So here it was 96, and this is equals to 0.85 to the power n. And by now, at this point, you should be comfortable with this method. Now I need to solve for my n. So my n, it should be equals to log of anything that was attached to my n. In this case, it is 0.85. And my exponent is anything that was on the other side. So the other side, it was 79,866. All right. And punching this into your calculator, your value of n should be equals to 5, right? So how many years ago did Sandile buy the car? It was 5 years ago. So 5 years ago. This is your final answer. Now let's look at 5.1.2. Now remember I said normally questions like this whereby you say 5.1.1, 5.1.2. To answer 5.1.2, you will be required to calculate, or rather to make use of the answer you got in 5.1.1. And even though this answer may be wrong or you may not have that much confidence in it, just continue using it here. You'll get a mark for doing that, right? So do not leave 5.1.2 blank just because you didn't understood how to go about doing this. You can just do the wrong thing here and take whatever amount you got here and try to use it here if maybe you understand this question better than this, right? Now 5.1.2 said at exactly the same time that Debo bought the car, all right? Now, which was 5 years ago, okay? Now, Bianca deposited 49,000 into a savings account at an interest rate of, so this is a fixed deposit of 49,000 into a savings account at an interest rate of 10% compounded quarterly. Meaning that in order to go about solving this question, we would need to make use of our compound interest formula. Now, has Bianca accumulated enough money in her savings account to buy Deboho's cars now? Now, this car is valued at 79,866.96, right? Now, we want to see if this person investment account started off with 49,000, which was compounded at 10% quarterly. Would it have enough money? Would his or her, rather in this case, investment account have enough money to buy this car, right? Meaning that would it have 79,866.96 or more? Now let's go about doing that. So we said we're going to make use of our compounding interest formula because we have a fixed amount, and this fixed amount, it has an interest which is compounded. So A is equals to P1 plus I all to the power n. Now let's substitute what we have. So what is the present value? This is the amount she invested, which is 49,000. So it's 49,000. So this is 1 plus, and the interest is 10%, right? So 0.10, and it's compounded quarterly. So I would have to divide this by 4. And my n, which is the number of years, it's 5. And remember, it's compounded quarterly. I would have to multiply this n by 4. All right. So punching this into the calculator, I should get a future value amount of 80,292,21. Right now, this is the amount that should be in Bianca's bank account, right, when this car is valued at 79,866. Now, to answer this question, yes, Bianca would accumulate enough money in her account to be able to afford the Bohos car, right? Because this is the amount that would be in her account. This is the value of the car, right? Now let's move on to the next question. Now they say exactly 10 months ago, right? Okay, let me just underline this part to show that it's separate from the above part and change the color of my marker. Now they say exactly 10 months ago, a bank granted Anita a loan of 800,000 at an interest rate of 10.25% compounded monthly. Now, what did I say with regards to loan? Always your loans, you will make use of your present value formula. All right. Now, let's see what the question requires of us, or rather, let us start by reading out this information. Now, they say the bank, all right, the bank stipulates that the loan must be repaid over a period of 20 years. All right, meaning that my n, because it's compounded monthly, so my n would be 20 multiplied by 12, and this should be equals to 240. All right. Now, this must be repaid by means of monthly repayments. They give us the monthly repayment that they require. Now, this is 7,852.15, starting 1 month after the loan was granted. All right, fine. Now, how much did Anita owe immediately after making his 6th payment? Now, this is very important. Now, we said also your N represents the number of payments. Now, this is in terms of months. Now, your N is 240 payments. Now, if they say how much did Anita owe immediately after his 6th payment, right, or 6th repayment, do you agree that we need to adjust our value of n? So in this case, our value of n would be 240 minus the 6 because we already settled for 6 months. So as a result, our n for this, to answer this question, it will be equals to 230. So it will be 234. All right. Now let's go about answer this question. And remember, we're making use of our present value formula because this is a loan. Remember, this formula is not given at the back of your question paper. So it's important for you to memorize it. Now let me just write it down. Now let's substitute what we have. All right. Starting off with our value of x. Now, starting off with our value of x, which is 7,853.15. Now, square bracket, 1 minus, so this is 1 plus my interest. Now, my interest was how much? So it was 10.25%. So let me just write it here. 10.25 percent. Now, this, remember, it's compounded monthly, hence I need to divide it by 12. Now, all to the power minus n. And we said our n is going to be this 234. So it's going to be negative 200. Now, my I, still 10.25%. Now, remember, this interest is compounded monthly, hence I need to divide this by 12. All right. Now, if I punch this into my calculator, I would find out that the amount that Anita is owing after making her sixth repayment, it's equals to 793,000, right? So it's equal to 793,749.25. This is the amount she owes. Now, let's go to 5.2.2. Now, I said what with regards to questions like this, when you have 5.2.1 and 5.2.2. So in order to go about answering this, I haven't even read this question, but then I would know that I need to make use of this answer I found here. Now, I said that even though your answer here might be wrong, but for the method that you took that wrong answer and used it here, you'll get a mark for that. Now, here they say due to financial difficulties as a result of COVID-19, Anita misses out on her seventh, which is after the sixth, right? Seventh, eighth, and ninth payments. She was able to make the payments from the end of the 10 months onwards. Now we need to calculate Anita's increased monthly repayments in order to settle the loan in the original 20 years stipulated by the bank. Now, this is something which is very important. Now, what are we required to calculate? The monthly repayments, which are increased, right? Taking into consideration this, we need to make an adjustment. Now, let me just separate these two parts. Based on this, we need to make an adjustment. And after we have made that adjustment, we need to calculate our X, which is what the second part is requiring us to do. Now, even though you do not pay your monthly installments, now let me make reference to this case, the 7th, the 8th, and 9th, your interest would still be charged, or interest will still be capitalized monthly, right? So we need to charge Anita interest for these months and see that after she missed these payments, or these three payments, right, taking into consideration the capitalized interest, how much is she now owing? And after we got that amount, which we use as a present value, we would need to calculate our X. Now let's just go about doing that. So I'm saying that I need to find out how much Anita owes after she missed these three payments. What is the outstanding total balance of the loan after she missed these payments? Now, how would I go about doing that? I would make use of this normal compound interest formula, because why? The one there wasn't any monthly repayments on the 7th and 8th and 9th, right, month. Hence, you can't make use of your annuity equation. In this case, there weren't any payments, right? Hence, we do not make use of our annuity formulas, your present value formula, to be specific, right? Now, we would make use of this compound interest. Future value is equal to my present value. So 1 plus my interest all over n. Now, at the start of the 7th month, right, which is the amount that we calculated here, Anita owed 793,749.25, right? Let me just erase this. Okay, so basically, this would be our present value, because this is the amount she owed. So 7, 9, 3, 7, 4, 9. Right now, 1 plus my interest. Now, my interest happens to be has changed, still the same, 10.25%. Now, this is compounded monthly, so I would need to divide it by 12. Now, what about my N? I said I want to find the amount this person is owing after they missed 3 payments. So my N would be 3 months, right? Because we're starting from the 6th up until the end of the 9th pay, the 9th month. So punching this into my calculator, I would find out that Anita is owing 814,000, right? Now, this is after she missed this 9th payment, right? She is now owing 814,000. And this is how you would always go about answering these kind of questions. First, find out how much are they owing, and then you can then calculate whatever they're asking you afterwards. Now, after she missed these 3 payments, she's now owing 814,263.3052. Now, we do not round off. Why? Because we haven't yet arrived onto our final answer. All right. Now, this is the amount she is owing. Now I need to calculate the monthly repayments in order to settle the loan within the original 20 years stipulated by the bank, right? Now, I would need to make use of my present value formula. Why? Because here there is an annuity. Why? There are monthly repayments which are equal and are made on regular intervals. So let me just first start by writing down my present value formula. Now, I'm calculating for my X. Now, remember the formula I showed you. In order to accurately solve for your X, just take out your X, right? X, then cross multiply. So this is the same as PV over 1. So your present value would multiply with your interest. So PV multiplied by your I, and then your 1 will multiply by this, and your denominator in this case, it should be 1 minus 1 plus I to the power minus n. From here, let's substitute what we have, and then we will punch this into a calculator, right? So this is equals to, let me just draw a line. Now, the present value, this is the amount they owe. So my present value in this case, it will be 814,263, 3052. Now, I need to multiply this by my interest, all right? So how much is my interest? My interest, I don't think my interest changed, right? So my interest is still, let me just confirm, 10.25% compounded monthly, right? So it's 10.25%. And this is compounded monthly. Now let me just write down on my denominator. So my denominator is 1 minus 1 plus my interest, which is 10.25%. And this interest is compounded monthly. Now remember, this is to your power negative n. Now what is my n in this case? Now the total months were 240, right? Now this person has missed, okay, they have paid, right? So we needed to calculate how much they were owing up until the 6th month. So it was 234. Now afterwards they missed 3 months. So we need to subtract 3 from this 234, right? So that our n could be equals to 231. These are the remaining repayments or months, okay, within the original, making reference to the original or initial agreements to pay over the loan within 20 years. So it will be 231, so minus 231. And remember to always close brackets this, because if you don't, it will give you an error, right? Now, punching this into your calculator, right, your x should be equals to, now this is the new monthly repayments, which are or has increased. It's 8,089,20. Now this is the amount that Anita would now pay as a result of her missing out the 3rd or the 3 months, right? As a result of her not paying the loan in these 3 months, her monthly installments would now increase to 8,089. And remember, before they were how much? They were 7,853, right? But this is how you go about answering this kind of a question. Now, if ever you have any questions with regards to this tutorial, always feel free to reach out. Enjoy the rest of your day. Thank you.